Welcome back. So now let's go ahead and get started on day one of our training. So I'm going to quickly run through the agenda. We are going to talk about the DevOps roadmap, which is very important. You all have decided to learn DevOps. So we need to have clear roadmap in front of us before we start our journey. So we'll talk about that. And then we will also talk about what are the various DevOps tools that would be covered in this coaching program. And then we will also talk about what are the typical roles and responsibilities of a DevOps engineer. Once you get a job, let's say after a couple of months, what to expect, from you, right, in the job. And then we will also talk about why companies are adapting into a cloud and whatnot. Okay, why companies are moving away from on-prem into cloud, right? And then we will also talk about what is SDLC. I understand some of you may not have background in software development, but still, I just want to briefly touch upon that. And then we will also talk about what is the difference between waterfall and agile, which is commonly practiced. Obviously, agile is commonly practiced, so we'll briefly touch upon that. And then we will also, pick up a use case, and then we'll try to understand what are some of the challenges that you may be facing once you get a job as a DevOps engineer, and then how you can, bring automation to the team, right? So we'll try to understand how teams are doing manually, and then how you can help them to achieve DevOps, right? And then automation and whatnot. So we'll also talk about that. And then we will also talk about how Agile and DevOps can work together, right? And then we will also talk about why companies are still hiring DevOps engineer. I understand, we are in the very fast, dynamic, moving world, but still why companies are adapting DevOps engineer, right? So we'll also talk about that. And then last but not the least, we will also talk about how you can actually configure your typical DevOps continuous delivery pipeline, right? So we will also talk about that as well. So now let's try to understand our DevOps roadmap. So if you look at this diagram, let's say this is you definitely want to become a DevOps champion, right? So how do you think you can reach from here into here? So let's quickly talk about that. As a DevOps engineer, you need to have strong foundational Linux knowledge. So we already talked about this as part of day 0, isn't it? So even if you do not have that skill set, you can actually subscribe to various courses in Udemy, or you can also go through YouTube or Google, whatever, right? So it is super important that you have fundamental Linux knowledge. And if you also have some scripting knowledge, that is also well and good. You can learn Python, or you can learn AML or Groovy or shell scripting. Any scripting knowledge if you have, that is going to definitely help you. If you do not have it, you can learn on the side, right? You can learn parallelly along with your DevOps learning course. And the next thing is having strong source code management tool knowledge, right? So as part of our curriculum, we are going to cover GitHub. We will also cover Azure Repos, and we will also cover some lab exercise using Bitbucket. So as a DevOps engineer, you need to have a strong SCM tools knowledge. So we will definitely cover as part of our curriculum. Okay. And then next pillars, and then the next pillar of DevOps is CI/CD, right? So as a DevOps engineer, you need to know how you can implement continuous integration and continuous delivery, right? So as part of this, we would be covering 3 various tools: Jenkins, Azure DevOps, and GitHub Actions. So this is where we will also, leverage, AML scripting language or Groovy scripting language in order to create pipelines. Okay. And then the next important pillars of DevOps is DevSecOps, right? So this is actually purely from security standpoint. Okay. So obviously, right, name a single company who's practicing DevOps not giving importance to security. I don't think so, right? So everyone wants to secure the application code, secure the Docker image, secure the pipeline, isn't it? So secure the infrastructure and so on, right? So there are various security scanning tool, okay, that you can actually learn. But as part of our curriculum, we are going to learn about a couple of tools, right? So we are going to learn about Trivy, which is again a popular security scanning tool for scanning your Docker image and so on, right? And then we will also learn about a tool called Chakao, which is again another SAST scanning tool for scanning your infrastructure files, such as Terraform or your Kubernetes manifest file or Helm chart and whatnot. so which can scan your files and then identify if there are any misconfiguration or if there are any security compliance, in your infrastructure files. And then we will also cover about SonarQube. I understand SonarQube is purely a static code analysis tool, but this also can perform some basic vulnerability as well. And then we will also talk about GitHub Advanced Security for Azure DevOps. So whenever we are going to do Azure DevOps lab exercise, so I will also talk about how you can perform security scanning using GitHub Advanced Security for Azure DevOps. And then we will also talk about infrastructure as a code as well as configuration management. So as part of that, we will be covering two different tools, Terraform and Ansible. And then the next important category, right? So containers. So think about this, right? Pretty much every company is moving away from monolithic architecture into microservices architecture, isn't it? So as a DevOps engineer, you need to know how you can Dockerize or how you can containerize application, right? So you need to know how to create a Docker file, how you can create a Docker image, how you can deploy Docker containers, inside Kubernetes clusters and whatnot. You should be able to know how you can automate the end-to-end lifecycle, right? So we would be covering Docker, we would be covering Kubernetes, which is a container orchestration platform, right? And then we'll also talk about Helm, which is nothing but a package manager for Kubernetes. So we'll also talk about that. And then we will also set up Kubernetes cluster, in AWS cloud. We'll also try to set up Kubernetes cluster in Azure as well, which is nothing but AKS cluster. And then we will try to create a CI/CD pipeline, and then we will automate the entire, life cycle, right? So we will do various lab exercises using these tools. And then we will also cover monitoring tool. Monitoring is very important, okay? You set up the infrastructure, but you need to, set up a monitoring tool, right? It's like this, right? Let's say you are living in a massive house. You are out of town, but something happened. If you don't have any CCTV camera, then it is very challenging for you, right? So same thing, right? Once you set up the infrastructure, we need to monitor our infrastructure so that, if there are any issues, with the node or with the application, you would be knowing immediately, right? So Prometheus and Grafana are the tools that we would be covering. And then last but not the least, as a DevOps engineer, we all understand that, right? You need to have strong cloud knowledge as well. So since this particular course is way it has been structured, we are learning DevOps, but we would be leveraging both AWS cloud and then Azure cloud, right? So we would be leveraging some of the services of both AWS cloud and Azure cloud. So yeah, so basically guys, so that is the roadmap, right? If you're able to do this, right? If you're able to cover each and every tool, what is mentioned in the roadmap, that is more than enough for you to become a DevOps champion. All right, I'm really excited guys. So now let's move on to the next slide. So this slide talks about what are the tools that would be covered in our course. I know I briefly touched upon this in the previous slide, but still there are other tools. There are some additional tools that also would be covered as part of this course. For example, I know we already talked about SCM. If you see here, we would also learn about a tool called Maven. So Maven is one of the popular build tool for building Java-based application. So we will integrate Maven with Jenkins or GitHub Actions or Azure DevOps, all our CI/CD tool. So we will integrate with Maven for building and packaging, mainly for Java-based application. And then CI/CD, we already talked about this. We will be covering this. And then under code quality tool category, so we will definitely cover SonarQube, and then we will also cover Jacoco. So Jacoco is a code coverage tool for, mainly for Java-based application. It can create a code coverage report by scanning Java source code. And then as part of SAST scanning, yes, we will be covering these tools. And then under project management category, we are going to learn about Azure Board, okay? And then under binary repository management category, we are going to learn about Nexus. And then we already talked about this, we will cover that. And then under collaboration tool category, we are going to talk about Slack. So Slack is a professional collaboration tool that can be integrated with Jenkins or GitHub Actions or Azure DevOps. So as soon as the build is done or deployment is done, you can send notification back to development team. So remember, sending that feedback loop, right? That is very, very important. Okay, so sending that feedback back to development team is very crucial as part of DevOps. So we'll talk about that. And then, yes, we are going to talk about, Docker, Kubernetes, and so on, right? And then, yes, we are going to practice on AWS and Azure Cloud. And then scripting, yes, we would cover Groovy scripting. We would, create some Ansible playbooks. We will also create some, Terraform files using HCL, which is a HashiCorp configuration language, which is kind of a JSON format. So we'll also talk about that. And then under container registries, where you can store your Docker images. So we'll also cover ECR, ACR, Docker Hub, and Nexus, right? And then monitoring, we already talked about, right? We are going to cover Prometheus and Grafana, and then Helm, which is a package manager for Kubernetes, right? Great. So let's move on to the next slide. So now let's try to understand what are the typical roles and responsibilities of a DevOps engineer. So this is very, very important, right? Now let's say you got a job after a couple of months, right? Now you started working with a team. So you need to have clear understanding, right? So what is the job expectations out of you, right? So now let's try to understand. So as a DevOps engineer, good news is you are not responsible for developing or coding the application, right? So don't get me wrong. You still have to write script, right? You still have to write some level of code, but we are not responsible for application code development. So that is done by a Scrum team, or that is done by Agile team. However, we will be working closely with the Agile team or Scrum team or IT team. So that includes developers, QA engineers, and infrastructure folks, and so on. So now let's try to understand the typical Agile team structure. So usually speaking, the typical Agile team structure would have 5 to 9 team members, right? Or 6 to 10 team members. But again, this can vary plus or minus, right? But let's try to understand the breakdown, right? So a typical Agile team would have a product owner. So product owner is the one who's going to, own the product. So they are the one who's going to act as a single point of, a customer, right? Like, for example, they are the one who's going to provide you all the requirements. So they would collect all the requirements from the business, and then they are going to create user stories and whatnot, right? So they are going to, create the backlog and so on, right? So they would be using project management tool, such as Rally or Monday.com or Jira and so on, right? Okay, so they are the one who is actually responsible for delivering the application to the business. Okay, they won't be technical person. Okay, but from a business standpoint, so business would not talk to a developers, right? So they would actually talk to a product owner. So they are the one who is responsible for delivering the application, and then they are also one who's responsible for giving any user requirements or any kind of information to the development team. And then the Scrum Master. So Scrum Master one is the one who's going to run the daily stand-up, right? And Scrum Master also will coach the team as well, okay? And then a team, typical Agile team may have 3 to 4 developers or software engineers or programmers, right? So it could be a combination of, Java guys or .NET guys or Node.js or full stack developer. The developer also you may also have some UI or UX developer or designer as well, right? As part of that, team. And then the team would have a DevOps engineer, that is you, right? So you would be closely working with the developers, QA engineers and infrastructure guys and whatnot, and then understand the requirements, and then you will try to automate whatever the manual tasks each and every team member is doing, right? And then one QA engineer. So either the team may have, 1 or 2 QA engineers. So one engineer could be a manual QA, engineer, or other person could be automation QA engineer. Again, team may have, depending on the team dynamics, okay? And then one business analyst, I put this as optional. So most of the companies these days, product owner is the one who's going to act as a voice of customer. And then they are the one who's going to provide all the requirements, details, and whatnot, right? But again, still a team may have a business analyst, and then one more person is as part of the team is a DBA, right? So DBA is nothing but let's say team is developing any application which is kind of needs a lot of database help and whatnot. So the DBA may help the team as well, right? So sometimes the DBA may work across multiple teams, right? So that is also purely depends. Okay, so yeah, so this is the typical agile team structure, guys. Like I said, 5 to 9 team members or 6 to 10 members, again, depending on the team dynamics and so on. And then, so what do you think the agile team is going to do every day? So please do understand, guys, once you get a job, so you would be, working closely with the agile team, but you should be able to answer these 3 questions every day, right? So you should be able to clearly communicate what did you do yesterday, what you're going to work on today, and if at all you have any impediments, right? Because you have to attend daily stand-up that would last again 10 to 15 minutes or 10 to 20 minutes. So you should be able to clearly communicate what are the tasks that you are working on, if at all you have any challenges and so on. All right. So yeah, I hope this was really useful, understanding the typical agile team structure. So now let's get back to our slide. Now we have clear understanding of agile team structure, right? So like I said, as a DevOps engineer, you would be closely working with the agile team, right? So understand how developers are working, how they are actually collaborating, right? And then identify any task that they are doing manually, right? And then you also need to understand what are their day-to-day challenges and so on, right? And then finally, you are responsible for creating the streamlined and then automated process, right? So that is what you would be doing. And then you would be automating the entire development lifecycle, right? You would be automating the way they are doing build, you would be automating the way they are checking their code quality and so on. So you would be creating this entire CI/CD pipeline starting from checkout all the way into production deployment, right? So you're going to automate each and every step of the way. All right. So I hope this was useful, guys. So this is a typical roles and responsibilities of a DevOps engineer. So now let's move on to the next slide. So now let's try to understand why companies are struggling, especially if they have set up their infrastructure on premises, right? So this also kind of give you a good view why companies are moving away from on-prem into cloud. So let's just pick up a simple use case, right? So now let's say you are working for a e-commerce online company, right? Let's say they have set up their entire infrastructure on premises. Okay, they're not on the cloud, but they have set up their entire infrastructure on premises. So now let's try to understand some of the challenges they may be facing, right? So for a typical e-commerce company, so when do you think they would have peak usage? So we all know that, right? So during weekends or during peak holidays, they're going to get a lot of hit, right, to their website. So how do you think they can scale up their application? Since they have set up their infrastructure on premises, do you think they would be able to set up the server, set up the networking when they wanted to scale up? I don't think so, right? That is going to take a lot of time, isn't it? So, and then what about after the peak session is over, what happened to the traffic? Let's say the traffic is reduced. So do you think they would be able to scale down just like that? I don't think so, right? Isn't it? And then they also need to have a dedicated server team to manage the infrastructure, right? Isn't it? So there are a lot of challenges, especially with on-premises model, right? So that's the reason why many companies are moving away from on-premises into cloud. So this slide talks about what are the advantages of moving away from on-prem into cloud, isn't it? So obviously, I mean, we all know that, right? There are so many advantages of, setting up your, IT infrastructure in the cloud environment. There are a lot of benefits, right? So one of the common benefit is elasticity, right? So obviously, right, you can, create the resources on demand, right? Auto scale, right? So you have all this auto scaling capability, right? And then better resource utilization, isn't it? So when I say better resource utilization, so like I said in the previous example, you set up the infrastructure during peak holidays, but what happened, especially if you're on premises, what happened, the traffic, the load is reduced, then what happened to the resources that you have already provisioned? It's all waste of money and so on, right? But when it comes to cloud, the way you can configure is, based on the demand, you can scale up, and then when the demand goes down, you can actually scale down. Okay. And then no upfront cost. So obviously, right, you don't need to spend a lot of capital towards your initial infrastructure, right? So you can start as low as possible, and then you would be able to go up. Okay. Obviously, you don't have to spend all the money, in maintaining data center and so on, and then you can go global in matter of minutes. So let's say you are running your e-commerce company, but let's say there is some huge demand somewhere in Australia, and guess what? If you want to attract your local users, right? So you would be able to set up something in that data center, right, close to Australia, isn't it? And then you don't need to have a dedicated server team to manage your entire infrastructure, right? Everything can be managed by the cloud platform itself. There are a lot of advantages of moving away from on-prem into cloud. All right, so now let's move on to the next slide. So now let's try to understand what do you mean by SDLC, right? So I understand some of you may not have background in IT, but let me quickly run through this. This is not very difficult. So if you're really wondering how companies are developing a software, right? So how do you think companies are developing a software right from inception into end product? So obviously, right? So these are the various stages involved. So obviously everything has to start with a plan, right? Everything starts with a plan. And then once you understand, the plan, once you perform, analysis and so on, and then you're going to create a design, okay? And then team can look up the design, and then they can start, implement the software, and then you're going to test it, and then you're going to deploy it. And then finally the product would be managed, right? So you may have multiple versions, you're going to manage your software, right? So basically, this is what we call different phases of software development lifecycle. So let's move to the next slide. There are so many ways you can actually develop a software, right? Waterfall is one of the oldest ways of developing a software, and then you have Agile, Scrum, Kanban, and so on. But this slide we are going to just talk about these two. So waterfall is obviously one of the traditional ways of developing software, which is not so popular. You would know just by looking at this diagram, right? It's like a big mountain for you to carry, right? Why? Because the problem with the waterfall is, you see here, right? Team is developing the software, but they are going to, release the product only in the end. But just think about this, right? Let's say business is waiting for 9 months. So business have given the requirements to the IT team. Let's say IT team is developing software for last 6 months or 9 months, and they are delivering the product after 6 or 9 months. But let's say whatever they have developed and delivered, let's say business did not like it. Then you can imagine, the time, money, efforts are being wasted right there, right? So it's a huge risk if you are implementing, if you are creating a software using waterfall methodology, right? So especially in this fast, dynamic world, waterfall would never work. So many companies have already moved on from waterfall into something called agile. So look at this diagram. So this clearly says this, right? So agile is nothing but you are breaking down your requirements into a smaller chunk of user stories, and then you are delivering the product, in a smaller chunk. So if you look at this diagram, you are kind of, delivering the product, in kind of a couple of weeks, right? So you're not taking forever, but you are taking maybe 2 weeks or 3 weeks, and then you would be taking, few user stories, and then you would be, developing, and then you would be giving, most importantly, demo to the product owner. So they can look at what is being developed, and then they can give a feedback. If there are any bugs, you can fix it maybe in the upcoming sprint and so on. And then yeah, so that is the best way of doing it, right? So basically Agile is like iterative way of developing software where business can see the value every sprint, isn't it? So that's the beauty of Agile. So basically, guys, so just to summarize this one, right? Waterfall is not commonly practiced anymore. Agile is what most of the companies are practicing these days. Okay, so that is what the difference between these two. All right. So now let's try to understand, right? Before we talk about DevOps. So now let's try to understand, you know, what are some of the issues or what are some of the challenges that you may be having once you get a job as a DevOps engineer, right? So let's try to understand that use case. So if you look at this diagram, so yes, this is kind of team is developing software, right? So team is developing software purely using Agile. So you see a product owner, they are the one who's going to create user stories. They are feeding into Jira, and then development team is taking from Jira, right? They are taking user stories, and then they are committing into a version control system or source code repository, right? And then now let's try to understand the problem. So like I said, let's say they don't have any automation. Let's say the team has very low DevOps maturity level, right? They are very good in Java, very good in .NET or Node.js and so on, but they don't have, let's say the Agile team don't have any expertise, in when it comes to DevOps. Okay. So you see here, right? So they are struggling. For example, so look at this senior developer. So what he would do, he would manually build the code and manually deploy the code each and every environment from his local machine. Can you imagine, guys? And you can see here, right? Everything is done manually. Build is done manually. The way they are running the test is done manually. Deployment is done manually. And there is no code quality tool. There is no CI/CD tool, right? There is no code coverage, right? And you can also see here there's no feedback loop, right? You can see here arrows are going one way. It's not coming back, isn't it? Okay, and then they don't even have a proper binary repository manager where they would be storing the build artifact. Everything is actually stored in the senior developer's machine. Just imagine what would happen if his machine is crashed, or let's say he had a fight with his girlfriend previous night and then he doesn't show up to work today. So what would happen? So single point of failure right there, right? Isn't it? And then last but not the least, you can also see all these environments were configured manually, right? They didn't have any infrastructure as a code tool. So, entire infrastructure was set up manually, which is again time consuming, right? So basically, this is the use case, right? This is a perfect use case for you to solve as a DevOps engineer, right? So now how do you think you can solve this problem? So now let's look at that in the next slide. So now if you look at the slide, I know a lot of moving parts, but let's try to understand one by one. So yes, you have a product owner. They are creating user stories, in Jira Rally, and the team is developing, work locally, and then they are committing into, version control system. Now the important thing is you see here, so you have this CI/CD server, right? Or CI/CD tool such as Jenkins. So now Jenkins plays such an important role, right? So if you see in the previous diagram, you didn't even have any CI/CD server, right? Isn't it? So nothing was automated, isn't it? Everything was done manually. So now you are going to introduce CI/CD to the team. So this one talks about clearly, this is a CI/CD, a typical CI/CD process flow diagram, right? So this is where you are going to implement DevOps to work with Agile team, right? So now let's try to understand this further, right? So what was the major issue over here? So this person have to manually build and then manually deploy. If there are any issues, he's going to communicate to each and every developer manually, right? But whereas here, once you configure your CI/CD server, right, such as Jenkins or Azure DevOps or GitHub Actions or Circle CI, again based on what CI/CD tool your company is using. So once you have configured your CI/CD server, you can create a pipeline, and then you can configure in a way, as soon as the application code is committed by a development team, okay, you can kickstart your entire CI/CD process, right? So you can trigger the build in an automated manner. As soon as build is done, so you can check out the code, you can run your unit tests, right? And you can perform code coverage checks. You can integrate with static code analysis tools such as SonarQube in order to find defects and whatnot. And then you can also perform security scanning as well. And then you can create a build artifact. It could be a WAR file or it could be a Docker image. You can upload into Nexus or Artifactory, which is nothing but binary repository manager. And then finally, you can deploy your application into your server, right? And then look at here, you can provide the feedback back to developers saying that build is done or a deployment is done and so on, right? So this is your typical, CI, which is nothing but continuous integration, right? So basically, continuous integration is nothing but it's a practice commonly practiced, in each and every agile team, where as soon as code is committed into a common repository, you would have some kind of a CI/CD pipeline that would trigger the build, that would do all the code quality check, all the code coverage check, all the security scanning and so on. And then it would give the feedback immediately back to developers if there are any bugs and so on, right? So that development team can take immediate action to fix those defects or those issues, right? So that is your CI part of it, okay? I also put gating over here, right? So gating is nothing but, let's say, during scan, let's say you are integrating with Trivi, or let's say you're integrating SonarQube, but let's say SonarQube found, critical defects. So obviously you don't want to deploy your code with the high defects, right? So you can provide the feedback back to developers saying the build has some issues and so on, right? So you can also do that as well. So you can create a quality gate. You can also force the build to fail when those conditions are not met. All right. So we understood about CI. So basically, like I said, the goal of CI is to find issues as soon as code is committed by developers by integrating with all the code quality tools, all the security scanning tool, and then report back to developers, right? So that is your CI. So now let's try to understand the CD. So CD, I understand, right? You can say continuous delivery or continuous deployment, but we would be practicing continuous delivery. Continuous deployment is nothing but you are even doing deployment into a production environment in an automated manner, but we are going to do continuous delivery where there would be some kind of a semi-automated process, right? So there would be some manual intervention, during the deployment. So now let's try to understand that. So now let's say you are doing your CI build, you are able to find, some bugs you are able to report back to developers. Now let's say, they have fixed those issues and they are committing the code. Now let's say Jenkins is checking out the code, running the build, and let's say Jenkins is deploying the code into dev environment. So now all the bugs are fixed. So now you have your deployable code ready, right? So now you have your build artifact ready. So now you want to deploy this into a next environment, right? So that is what called continuous delivery. So continuous delivery is nothing but it's an automated way of deploying your code into higher environment. I would say semi-automated way, maybe with some manual intervention, here and there, right? So now let's try to understand. So let's say, you have deployed into dev, you inform development team. Now developers are going and testing it. Now they are confirming we are good to go. So now you can deploy the code into a QA environment. Again, you can also have your quality get configured and so on, right? It can check for any issues. For example, you can configure in a way that you don't want to deploy if the code has less than 100% unit test execution, right? Or the code coverage has to be 80% or 85% or 90%, right? Something like that you can configure in a quality gate, and then you can check if conditions are not met, you can force the build to fail, but if conditions are met, you can move forward to next environment. So once you deploy into, let's say, QA environment, If you have any kind of a QA automation test, so you can perform additional test run. So this is where you would be working with a QA automation engineer, right? So they may be using Selenium or Cucumber, so they may have their test automation suite developed, so you can integrate with them after you deploy into either QA or UAT environment. Okay. And then finally you can deploy the code into production environment, right? So if once everything is good, and then entire infrastructure, you see here, entire infrastructure can be configured using either Terraform or Ansible or any kind of a infrastructure automation tool or configuration management tool, right? So yeah, so basically, so this diagram clearly talks about, right? Yes, this is agile team, and again, same thing, right? This is agile team, but how we are bringing DevOps, how we are bringing CI/CD to the existing agile team where they were doing manually. Now you are, trying to automate every possible manual task, isn't it? So yeah, so I hope this is clear, but we will be coming back to this diagram. We will be referring this diagram, for many of our lab exercise when we are going to implement CI/CD. All right, awesome. I hope this was useful. So now let's move on to the next slide. So now I think we have fair idea about what you mean by DevOps, right? So where you are, bringing all the best practices and whatnot, which is going to help, development team and then operation team to shorten the development lifecycle in order to deliver, high quality software in a continuous manner, isn't it? So we saw in the previous diagram, when you implement CI/CD, so it is kind of guaranteed that, you would be able to, deliver quality software quickly in an automated manner and so on, right? So that's the beauty of DevOps is all about, right? So obviously you take any company, they may have customers. So how quickly you can, build the software, how quickly you can release the software, and then most importantly, how quickly you can get the feedback and then, apply if there are any bugs, so that in the upcoming releases, you're not going to have those defects, right? So that is what, guys, DevOps is all about, right? So you don't want to take a longer time to develop the software. You want to take very less time, but you want to, deliver the software in a high quality manner and then in a continuous manner. All right. All right, so now let's quickly talk about how Agile and DevOps can work together. I know we kind of understood in this particular diagram, but let's quickly talk about that, right? So obviously, right, so Agile is a methodology used for software development where you are going to, split your big requirements into a smaller chunk of user stories, and then team is going to, deliver the product or deliver the software in an iterative manner, right? So typically, every 2 weeks. And then you can clearly see here, so this is business, and then you see here, this is a development team. So kind of Agile is kind of bridging the gap, isn't it? Where you are developing software, in an iterative manner, right? And then you also have retrospective and whatnot, and then you can always give feedback and so on, right? So that is your typical agile software development methodology, right? And look at DevOps. So DevOps is clearly, so you have a development team and then you have an infrastructure team, right? Or operation team. You are bridging the gap between these two by doing the automation work, right? So what kind of automation? Yes, you are implementing CI/CD, you are automating, infrastructure, you are automating the infrastructure setup, you're automating the configuration management, monitoring, and so on, right? So that is what DevOps is all about, right? So it's a practice followed by IT teams in order to automate the manual task, right? So you are involving all the teams to work together. And then most importantly, you are providing the continuous feedback. So you see here, look at the arrows. Arrows are going back, right? In pretty much every stages, correct, guys? Isn't it? So that is the key when it comes to DevOps. Okay, and obviously it is also a cultural shift, right? Because just imagine, let's say you are a developer, you have been doing software development, let's say for past 10 years or 15 years, you have been doing, you have been like doing deployment manually. So now we are talking about all these tools, right? So obviously you need to start embracing, DevOps, right? It's a cultural shift right? It's kind of a change in your mindset, isn't it? So which is very, very important. Okay. And then guys, so DevOps is not specific to, any tool or technology, right? It's not tied up to any specific tool or technology. So this is completely technology agnostic, right? So, it doesn't matter if you look at this diagram, it doesn't matter what kind of software they are developing, right? What kind of a technology stack it is. And you can still implement CI/CD, right? For example, using Jenkins, you can automate pretty much any technology stack. Using Azure DevOps, you can automate any technology stack. Using GitHub Actions, you can automate any technology stack. Only thing is you would be using the respective build tool. For example, for Java, you may be using Maven. For .NET, you may be using another build tool, right? So now let's try to understand why companies are hiring DevOps engineer. So this is $1 million question, right? So I understand every company has started practicing AI, machine learning, and so on, but still why there is a huge demand for DevOps engineer, right? So now let's try to understand. So faster time to market. So obviously, right? So we talked about very clearly in this diagram. So you have this CI/CD implemented. So obviously, right? Once you have your CI/CD implemented, which is the fundamental building blocks of DevOps, it is guaranteed that what you would be able to release the software into marketplace quickly, right? Not quickly, but you also would be able to do it on a continuous manner. And then quality is guaranteed, right? Because you are integrating various tools, Jacoco, SonarQube, some security scanning, Trivi, and so on. So it is guaranteed that, quality would definitely improve. Better performance, reduce outages, and then better products, right? So these are all from business value standpoint, okay? Now let's try to understand what are some of the technical benefits to the team. So communication between the team improves. So obviously, right? So if I can go back to this diagram, do you see the team is collaborating well? So just take this simple use case, right? Let's say this developer one is working, let's say is working in US. Developer two is, let's say, working in UK. And then let's say this developer is working in India. So they're all working in 3 different time zones. They don't have proper CI/CD tool. So how do you think, when there is a build issue, how do you think they can communicate? Even when they communicate, no one would be there, right? They are working on 3 different time zone and so on, right? So that's the biggest drawback over here, right? But when you're implementing DevOps, you can see here, right? So Jenkins, as soon as code is committed by development team, Jenkins is going to check out the code, start building, and then start integrating all this code quality tool. If there are any issues, Jenkins is going to send a feedback to each and every one of them. You understand, right? So it's kind of an instant feedback Jenkins is going to provide as part of CI build, right? So that's the beauty of implementing CI/CD, right? So yeah, so communication between team is definitely going to improve. And then faster resolution of problem, right? So team is not going to spend hours and hours in order to identify what is the issue, because you would know right away. And then better productivity, right? Just imagine, if you don't have CI/CD in place, you're going to spend a lot of time identifying issues and whatnot, and then you would not be able to even do your own work, right? Isn't it? So yeah, so that's another advantages of implementing DevOps, which is increased productivity. And then last but not the least, infrastructure as a code, right? So you can set up your entire infrastructure through code. Instead of doing it manually, you can set up the entire infrastructure through code. So that's a huge technical benefit, right? So which is definitely going to help you, so that you are not going to run into any issues and so on, right? So yeah, so these are some of the reasons, guys, why companies are adapting into DevOps culture, why they are hiring DevOps engineer. Great. So now let's try to understand the DevOps continuous delivery pipeline target state. So now let me give you some context. Okay. Now let's say you got a job as a DevOps engineer. You started working with the team. Okay. Now your manager is asking you very clearly, hey, you know what? He's telling you, hey, our DevOps maturity level is low. We don't have any automation in place. So he's telling you the situation is like this. Now he's asking you, hey, can you give me the target state? Okay. How do you think we are going to solve this problem, right? We want to bring DevOps, we want to bring automation end to end, and how it is going to look like, let's say, 6 months down the road or 9 months down the road, right? Or 12 months down the road, how it is going to look like. That is exactly what this diagram is all about, right? So if you look at this diagram, so let me run through it, right? So this is how you want to actually implement your continuous delivery pipeline, right? So if you see here, so team is taking work from Jira. I just put Jira as an example, okay? Jira or Rally or Monday.com. So it could be any project management tool, right? So let's say the product owner is creating user stories, in Jira. Now team is, started developing the code. They are committing into, let's say, GitHub. So team also have, obviously they would be using IDE, right? So they can also, install Sonar Lint, which is again a plugin for Sonar Cube. So they can, self-review the code by integrating with Sonar Cube. If there are any issues, they can also fix it locally before they commit the code into GitHub. Now let's say, they commit the code, obviously, right? So Jenkins can check out the code. It can start the automated build process, right? So along that, Jenkins can integrate with various tools, right? It can integrate with JUnit or Selenium and so on. It can also integrate with SonarQube. It can also integrate with, let's say, Fortify, which is another vulnerability scanning tool. And then, finally, Jenkins can build that artifact, right? And then artifact can be published into Artifactory or Nexus, right? And then finally, Jenkins can start doing the deployment, right? It can start the continuous delivery process. So it can start with the dev deployment and then QA deployment. Obviously, we also have security gate here, right? And then the entire infrastructure can be provisioned using either Terraform or Docker containers and so on, right? Okay. And then you can also see here, there are some additional testing run over here. You see here, there are some additional testing run over here. And then finally, the feedback is passed back to developers, right? So basically, you have this ability to do, continuously, automatedly, right? So you have this ability to do it in a continuous manner, automated manner, and then repeatable manner, right? So that's what your DevOps continuous delivery pipeline is all about, right? So as a DevOps engineer, we are all responsible for, setting up each and every tool, not just setting it up, right? But also integrating, right? Integrating all this tool, and then implementing DevOps. So that is what, guys, expected, out of you as a DevOps engineer, or as a DevOps lead or DevOps architect. All right. I hope lecture was really useful. I'm really looking forward to see you guys in the next lecture.